Okay, this is test 3 review. There are 29 questions. First question is from section 6.1. When normal probability distribution becomes standard normal probability distribution? The answer is when the center is 0 and then standard deviation is 1. Question number 2. The g-score is given. We need to find out the area under the curve. So as you can see here, I can find this answer by clicking Stat Crunch and then Stat Calculator, Normal Calculator. I just have to fill out the right side of the curve, which is right side. So instead of less or equal, you have to make it greater or equal. And the g-score means the middle box, which is negative 0.085. And if you hit compute, negative 0.85, not 0, negative 0.85. So if you hit compute, that will give you 0.8023. That's why the answer is 0.8023. When you go to the next box, next question, go to the same problem here. Instead of the g-score, this time we have given area, which is 0.1446. So you have to fill out the right side and then hit compute. It will give you the answer. Keep in mind, you have to choose the correct side. In this case, the shaded region is on the right side. That's why greater or equal is the right options. Now this is the g-score 1.06. If you choose 1.06, supposed to be the right answer if you choose 2 decimal place. Let's go to the next problem. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with the mean 0 and standard deviation 1. Find the probability that a given score is less than negative 0.186. So less than, find the probability that a given score means z-score, is less than. So the area is supposed to be on the left side of negative 1.86. So this first one is the right graph. And then the probability you can find by using the same calculator. Just go here and then I'm going to just replace the g-score, supposed to be negative 1.86, but also make sure that the area is on the left side. So you have to choose this as a less or equal so that you can see the very similar type of graph on this calculator. If you hit compute, the right side thing, this box represents the area under the curve, and if you want to round it to the 4 decimal places, it would be 0.0314. so it's a 0.0314, and if you check the answer, that's right. Let's go to the next problem. Assume that again when it's a bone density test, mean is 0 and then standard deviation is 1. That means it's a standard normal distribution. Find the probability between negative 2.09 and 3.88. That's the g-score. So we need to find out the area under the curve from negative 2.09 to 3.88. So this is the right graph. This is the right picture here. I'm going to choose that one. And for finding the area, we can choose the very same calculator, but this time you have to choose between from negative 2.09 to positive 3.88. When you hit compute, it's going to give you the shaded region here, and then area under the curve would be 0.9816. 0.9816 if you round it to the 4 decimal place. Okay, let's go to next problem. We need to find out one more time. It's a standard normal distribution, but we need to find out the value of P12, which means the 12th percentile. What does that mean? This is the bone density score separating the bottom 12%. So to the left side, there's supposed to be 0.12 area, and to the right side, there's supposed to be 0.88. So if you try to plot the graph of this thing, you are looking for a value such that to the left side the area under the curve would be 0.12, and to the right side the area of the curve under the curve supposed to be 0.88. So this is the value we are looking for. So if you check the graph we have given, then we can see that this one is the right one, because to the left side it's a less value. So this is the right graph. And what's the value? You can use the calculator here. Again, the standard one. To the left side, the area is 0.12. So this middle box is going to give you the 12th percentile P12 value, which is negative 1.17. Negative 1.17. Okay. Okay, the weights of the chocolate in Hershey Kisses are normally distributed with a mean 4.5338 gram and standard deviation is 0.1039 gram. For the bell-shaped graph of a normal distribution of the weight of Hershey Kisses, what is the area under the curve? So, for the bell-shaped graph of the normal distribution of the weight of Hershey Kisses, what is the area under the curve? The area under the curve, so here, as you can see here, area under the curve is it's a probability, it's a 1. In this case, keep in mind the mean we have given, it's a 4.5338, and then standard deviation is given, which is 0.1039. So we're going to use the same calculator, but to answer the first question, so what is the area under the curve? That's 1. That's the area under the curve. What is the value of the median? The value of the median is same as the mean, which is 4.5338. What is the value of the mode? That is also again the same value, 4.5338. What is the value of the variance? So variance is, it's a square of the standard deviation. So standard deviation is 0.1039. So what is the variance? That's the square of the standard deviation. So I can just use the calculator here. It's a 0.1039 whole square. So it's a 0.0108. 0.0108. Let's check. Okay, so that's the right answer. So area under the curve, always for the bell-shaped normally distributed curve, that's supposed to be 1, and mean, median, and mode, they are same. Variance is square of the standard deviation, and standard deviation is given. I just square that. Here we have given the IQ test, IQ score for normally distributed data. So we have to find out the area under the curve to the left side of this curve. So just go to the normal distribution calculator the way I, either you can use this table, but I don't want you to use this table. Just use the StatCrunch always. Go to the very same calculator, normal calculator, and plug the value of mean, which is 100, and then standard deviation, which is 15 in this case. We would like to find out the value of area under the curve to the left of this 90 score. That is 0.25. So if you round it to the 4 decimal place, it's 0.2525. This time again we need to find out the area under the curve, but to the right side instead of left side. So you can use the same calculator, but instead of left side you have to just change greater than, and instead of 90 this time you have given 87. The calculator is same, the value of mean and the standard deviation, they are same. So the answer is 0.8069. 0.8069, 4 decimal place. Okay, we need to find out the area under the curve in between 80 to 110. So go and use the same calculator, but instead of a standard calculator, use a between calculator. And remember, the mean is 100 and then standard deviation is 15, and we would like to find out the area under the curve from 80 to 110. Compute. That's 65, 63 if you round it to the 4 decimal place. 65, 63 if you round it to the 4 decimal place. Okay, assume that adults have IQ score that are normally distributed with the mean 97.8 and standard deviation 21.7. Find the first quartile Q1. Remember, the first quartile means which separates the 25% of the data to the left side. The area under the curve to the left side is 25. So the first quartile, like this, is it's a normal distribution, and then mean is 97.8. That's the mean. Standard deviation is 21.7. First quartile is area under the curve to the left side is 0.25. So that's the value we would like to find. So go and use the start crunch one more time and go to the normal calculator and just fill out this information. Mean is 97.8, standard deviation is 21.7, area to the left is 0.25, and if you hit compute, the value inside this middle box is your first quartile, and if you round it to the 1 decimal place, it's 83.2. 83.2 is the first quartile. Okay. Next question. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all adults. Accommodating 100% of adults would require very wide seats. That would be much too expensive. Assume adults have hip width that are normally distributed with a mean of 13.7 inch and standard deviation is 0.9. Find P99. That is, find the hip width for adult that separates the smallest 99% from the largest 1%. You use the same calculator, but you know the values of the mean and then standard deviation, you have to replace that. The mean is 13.7 inch. Standard deviation is 0.9 inch. You want to find out the value such that to the left side of that value the area under the curve is 0.99. So if I hit compute, that's going to give me the value 15.8 if you round to the 1 decimal place. 15.8 if I round it to the 1 decimal place. Okay, so that is, check answer. Go to the next problem. Assume that females have pulse rates that are normally distributed with the mean 74 beats per minute and standard deviation 12.5 beats per minute. Complete part A through C. If one adult female is randomly selected, find the probability that her pulse rate is less than 81 beats per minute. So for this particular part, you are going to use very same normal calculator with the mean 74 and then standard deviation 12.5, and you want to find out if one adult female is randomly selected, find the probability that her pulse rate is less than 81. So in the middle box, less than means this is the sign. The pulse rate is 81. Find the area under the curve. The area under the curve which gives you the probability, which is 0.7123. 0.7123. Now to answer this next question, instead of one adult female, now we are choosing 16 adult females. So in this case, if you go to the 6.4 chapter, you can see that whenever you have given sample, your mean would be same as original mean, but your standard deviation is a standard deviation of the original population divided by square root of n, where n is the size of the sample. In this case, sample size is 16, so when you go back to the same calculator, your standard deviation would be 12.5 divided by square root. So I'm going to type SQRT, that means square root of 16. And now we want to find out the very same information for this, and if you hit compute, that will give you 0.9876, 0.9875. If you round it to the 4 decimal place, 0.9875. Okay, this is for individual person, this is for sample group of females. Why can the normal distribution be used in part B? Because the original population is normally distributed, so we can use the normal distribution for the part B. Since the original population has a normal distribution, the distribution of the sample mean is also normal. Okay. Next. Okay, the overhead reach distance of adult females are normally distributed with the mean 202.5 centimeter and standard deviation 8.3 centimeter. Find the probability that an individual distance is greater than 212.5 centimeter. So this is exactly same as previous problem. You have to go to the normal calculator. You have to replace this mean, which is 202.5. Standard deviation is 8.3, and then find the probability that an individual distance is greater. So this time you have to choose greater than sign, is 212.5, and if you hit compute, this is the probability. If you round it to the 4 decimal place, it's a 0.1141, 0.1141. If you want to do the same thing but 15 randomly selected sample, then you have to divide this standard deviation by square root of 15. That's the formula. Now this time if you try to find the probability, then it will be different. Okay, so probability is 0.0000. so if you round it to the 4 decimal place, it's a 0. Okay, choose the correct answer. Why can the normal distribution be used in part B? Because the original population is normally distributed. It's similar to the question number 30. The normal distribution can be used because the original population has a normal distribution. What did I do wrong? Find the probability that the mean for 15 randomly selected distance is greater than, okay, it was different number, but I used the different numbers. I used the same number 212, so that was my mistake. I did not read part B, so just let me just replace this value by 201.20, and then if I hit compute, that gives me 0.7279. Let's check the answer. Okay, this time it's absolutely right. Okay, this is exactly the same same way you have to do like I did question number 13 and 14, so I'm going to skip this. Question number 16. A magazine provided results from a poll of 500 adults who were asked to identify their favorite pie. Among the 500 responded, 12% chose chocolate pie, and margin of error was given as a plus minus 4 percentage point. Given specific sample data, which confidence interval is wider? The 95% confidence interval or 80% confidence interval? Why is it wider? Okay, so 80% confidence interval would be wider. So the answer is supposed to be one of the answers, C or D. And 80% confidence interval must be wider than 95% confidence interval in order to be more confident. Okay, if you need the bigger confidence interval, that's supposed to be the wider range. So the answer is the first one. A 95% confidence interval is wider. Second one, to find the G-score for alpha over 2. Remember, alpha means it's a 4%, so alpha over t is 2%. So this is the g-score for such that the area under the curve of normal distribution to the right side of that g-score is 0.02. So you use the that normal distribution calculator. You go to the start crunch, find the normal calculator, area under the curve to the right side is 0.02, right side, so it's supposed to be greater than. So for that, this z-score is the critical value, 2.05. So these are the value we already have given. Actually, I already did this problem and then I thought it's a recording, but for some reason it was not recorded, so I have to redo this again. So these values are already filled out. Okay, so that's okay. This is a question from section 7.1, sample proportion. These are the values you have given, and to answer the question for 7.1, you have to go to the stat crunch and then go to the proportion stat, one sample with summary, and fill out this information. For this particular question, as you can see here, a drug is used to help prevent blood clots in certain patients in clinical trials among 4,640 patients. So that is the total number of observation, 4,640 patients. Out of that, 151 developed the adverse reaction. So that's the success for this particular experiment, and we need to construct 99% confidence interval here. And just if you hit compute, this table is going to give you information you are looking for. The sample proportion is here. That's the first question. To find the margin of error, you need to subtract this lower limit from the upper limit and divide by 2. This is the upper limit minus lower limit and divide that by 2, and that gives you this value. And then you just have to fill out this this lower limit, which is 0.02526 here, and then 0.039 here, and finally the meaning of this 99% confidence is this one. This is exactly the very same problem, the very same way you can do this problem. Go to the start crunch, find out this calculator, that proportion calculator, and then fill out this information. The total number of observant is 858. Total number of observation in this problem 58, and then out of 858, 426 boys. That's the success, and then we're looking for the confidence interval 95%. So when you hit compute, it's going to answer your question. This is the lower limit, this is the upper limit, and then this is the meaning. Very same question. I'm going to skip that. Question number 21. Here you need to use formula from section 7.1. The first formula, if you know the sample proportion, and the second formula if you don't know the sample proportion. In this problem, for the first case, you don't know the sample proportion, so we're going to use the first formula, this second formula, this one. And for this problem, for 95% confidence interval, you can find the g-score, which is 1.96, using the normal calculator. Because alpha is 5%, alpha over 2 is 2.5%, so that's how you can find 1.96. And then margin of error is 2%, it's given, so divide this by this, square it, and then multiply by 0.25. That's going to give you this number. For the second one, since you know the proportion, which is 17%, so instead of 0.25, you multiply that by 0.17, and Q is actually 1 minus P cap, which is 0.83. If you multiply all this number, it's going to be 1355 point something, and if you round it to the up integer, that's 1356. A point estimation is a single value. That's the question number 22 and question number 23 is the meaning of a confidence interval. This is the meaning. Question number 24. Question number 24, you have given some information and then you need to find out the t-score. For finding the t-score, you go to the start crunch and you go to the calculator, start calculator, and there is a t calculator. Here you are going to put the value for the degree of freedom, which is sample size -1. Here in this case it's 36 minus 1 is 35, and you want to find out the t-score for alpha over 2. Remember, alpha comes from the confidence level. In this case alpha is 1%, alpha over 2 is 0.5%, which is 0.005. So you are looking for the value of t-score such that the area to the right, so you change that to the right, area is 0.005, which is 0.5%. So that is the t-score, which is 2.72. 2.72, that's a t-score, 2.72. What is the margin of error? Margin of error is it given here? Okay, we can calculate the margin of error, but for that let's use the start crunch. Here we can go to stat, we can go to t-stat, we can go to one sample with summary, and we can just use this information here. The sample mean is 3211.1 gram. Sample standard deviation is 689.4 gram. Sample size is 36, and confidence interval needed is 99%. So when you hit compute, it's going to give you the upper limit, lower limit, and then sample mean it's already given. From these two values, upper limit and lower limit, you can find margin of error. Margin of error is upper limit minus lower limit divided by 2. So you can always use this value. In this case, look at here. The upper limit is 3524.0653 minus lower limit is 2898.1347, and divide this by 2. That's the margin of error, which is 312.96. And if you round it to the one decimal place, it's a 313. That's the margin of error. So now what is the confidence interval? Confidence interval is this values, lower limit 2898, a point 0.1, if you round it to the one decimal place, 2898.1, and then upper limit is 3524.1, 3524.1. Right? One more time. It's a 3524.1. Yes. So the meaning is one has 99% confidence that the confidence, one has 99% confidence that the interval from the lower bound to the upper bound contains the true value of the population. Means that's the meaning of this problem. Okay, this is exactly same as the previous problem. You have to just use the same calculator and answer the question. So I'm going to skip it. 26. That is also the same thing. You have to use the same calculator. So I'm going to skip that as well. This time, instead of the summary, you have to use the data. So just whenever you see that, open this in start crunch and go to the stat. Go to this t-stat with the data, and select the column for the data, which is this column, variable 1, var 1, and use the confidence level, which is what is the confidence level? 99%. It's 99% given, so 99. Hit compute, and it's going to give you the information you are looking for, which is lower limit 126.33, 126.33, and then upper limit is okay. This is the previous problem. 126.33, 141.005, 141.05 if you round it to the two decimal place. Okay. This question required different formula. The sample size from section 7.2. The sample size is what is that formula? This is the sample size, which is G-score times the standard deviation divided by margin of error. So that's what we need. Let me write it down. G-score sample size can be calculated. Find the critical value for alpha, multiply that by standard deviation of the population, and divide that by margin of error, and square that value. That's the sample size. So what's the question here? The question is find the sample size needed to estimate the mean age of movie patrons such that it can be said with 98% confidence that the sample mean is within 3 years. So remember, alpha is 2%. So alpha over 2 is 1%. So for that, you have to find out the G-score. And the margin of error, it's given that 3 years. 3 years of the population mean, and then population mean is the standard deviation is 19.3 years based on the previous standard deviation is 19.3. That's given. So you just need to find out the G-score here for that alpha. Okay. And how do you do that? You just go to the normal calculator and find out, use the normal calculator and find out the value H 0.1. It's a 1%, greater than, and this is the G-score 2.326. So here we have G-score. N is 2.32 times this is the standard deviation 19.3 divided by the margin of error 3, and then just multiply this and divide this and then take this square. So that is 2.33. Sorry, if you round it to the two decimal place, it should be 33, but I'm going to take up to 3 decimal place, so 326 2.326 times it by 19.3, and then divide that by 3, and then take the square of that, which is 223.91. So if you round it to the next integer, it's a 224. The sample size is 224. Okay, so the sample be obtained from one movie at one theater. Find the sample size needed to estimate the mean age of the movie pattern. No, that's not the right way to collect the sample. The sample should not be obtained from one movie at one theater, because that sample could be easily biased. Instead, a stratified sample of the broader population should be this is the right one. The sample should not be obtained from one movie at one theater, because that sample could be easily biased. Instead, a simple random sample should we should take the simple random sample. Which of the following is not a property of the student T-distribution? The student T-distribution is different for different sample size. That's right. The student T-distribution has the same general symmetric bell shape as the standard normal distribution, but it reflects a greater variability that is expected in the small samples. Okay. The student T-distribution has a mean of T equals 0. The standard deviation of the student T-distribution is the standard deviation of the student T-distribution is 1. So to answer this question, if you go to the 7.2 section, there is a property, it tells you about the student distribution. Okay, key points about the student distribution. The student distribution has the same general shape, and then student distribution has the mean at 0, but just as a normal distribution, but the standard deviation is not equal to 1. So the standard deviation is not equal to 1. So that's not part of the property. Okay.